Welcome you all for today's discussion. Today we are going to discuss about Pascal's law. Everyone know that Pascal's law is very important because it has wide range of application, engineering application and daily application, daily usage application. Most of the applications are, for example, these are for hydraulic jack, hydraulic brake, and power transmission system using hydraulic crane and multi-level parking. We can use concept of Pascal's law. So it's a very important law where we can save lot of by applying very less effort, very small force. We can lift very big, very heavy load. That concept is very useful in engineering applications. So today we are going to discuss how we can derive. We are going to discuss Pascal's law and how to derive Pascal's law. First we state what is a Pascal's law. So let us see what is a Pascal's law. So according to Pascal's law, for any liquid, it is applied for any liquid, whether it is a water or it is oil. So for at a given point in the liquid, suppose there is a filled liquid. Suppose this is a filled liquid, and this is a liquid container. Suppose at this is a point where we want to consider. At this point we want to consider. So here we can define Pascal's law. Suppose Px, and here direction Py or P theta, and here it is a Px. So at this point, this is a point of consideration according to Pascal's law, that intensity of pressure at given point is same and remains constant in all directions. It is not direction dependent. It is a same at given point. At the same level, at given point, pressure intensity remains constant and equal in all directions. This is a Pascal's law. So let us see how we derive Pascal's law. Px equal to Py equal to P theta. How we can derive this Pascal's law. So let us make we take a small triangular wedge. Here we take very small triangular, means infinitesimally small triangular wedge. So let us see, inside a liquid, this is a infinitesimally small triangular wedge having thickness unit. So this is a small triangular wedge, and this is A and B, and this is A, B and C, and thickness is 1. So let us define thickness. This is the thickness of the wedge, and this is the thickness of the wedge, and joining this, and this is direction x, and this is direction y, this is direction y, this is direction y, and this is the direction z. In this direction we can take thickness, that is direction z, A, B, C, and let us join. This is point O, C, D, and E, and we take thickness 1. Thickness is 1 and 1. Along z direction, thickness is 1. So this is a very small, and dimension of AB is dy. Dimension of AB is dy, and it is dx. Along the f direction, dimension is dx. So we consider here forces, pressure forces are acting. So pressure is acting here along f direction, it is a Px, and along y direction it is a Py, because it is inside the liquid. So whole area is filled with liquid. This is filled with liquid. If it is filled with liquid, and inside the liquid we have taken very small elemental triangular wedge. So this is a very small elemental triangular wedge, and along this direction AC is equal to ds. AC length of AC is equal to ds, and along this surface pressure force is acting P theta. It is arbitrary direction P theta. It is pressure acting. So we will enhance this one. Let us say this is area, this will be area, and this will be area, and this is also an area. So acting at theta, so you can resolve this is a P theta, this is theta at angle theta, acting at this surface at angle theta. So we extend this one, and you see that this angle is theta, and so this angle is also theta, and here you see this angle is theta, this is also theta. So this angle, if it's 90, so this angle 90 minus theta, this is equal to theta. Angle BAC equal to theta. And here we resolve P theta into two directions. P theta, vertical component P theta, sine theta, and here horizontal component p theta cos theta, and this length is ds. So resolving forces along x and y axis. Also we will consider gravity force, weight of this elemental triangular wedge. So see, weight of this elemental triangular wedge, weight of the wedge that will act downward. Weight of the wedge, weight of the wedge, weight of the wedge, weight of the wedge equal to 1 by 2 dx dy rho dx dy, because thickness we have taken 1, so multiplied by 1 and multiplied by g, so it is equal to 1 by 2 dx dy rho. Suppose it is a water, it may be any fluid, so rho g, and it will act downward, vertically downward. So it will act, suppose it is acting at this point, so it will act vertically downward. This weight of the wedge of this fluid, because it is inside the fluid, so it is weight of the fluid that is acting downward. We will consider while resolving forces. So sigma fx, force acting on the force acting on side AB. AB means area, we will consider area of this one, BOEA, means pressure px into dy into 1, because the thickness we have taken 1, so equal to px and dy. And force acting along BC, force acting along side BC, that is equal to py dx into 1. So py dx. And force acting along AC, and length of AC we have taken ds. This length of AC taken ds, and thickness is 1. So force on surface ACDE equal to P theta ds into 1 means P theta ds. So now resolving forces along x, y and z direction, because this element is under equilibrium, so forces along x, y and z direction will be in equilibrium. So sigma fx should be equal to 0, and sigma fx means forces acting along x direction means px dy and minus ps ds. P theta ds means a component along the x direction to cos theta equal to 0. So putting value of cos theta from triangle ABC, angle BAC equal to theta. So cos theta equal to dy by ds. So px dy minus p theta ds to dy by ds. So ds removed equal to 0, and dy also removed. So px equal to p theta. This is equation number 1. Now similarly we also resolve forces along y direction. So sigma fy equal to 0. Sigma fy equal to 0 means py into dx minus 1 by 2 dx dy rho g minus, if it is a downward force weight of the weight of this fluid inside the wedge acting downward, and vertical component of p theta also acting downward, so p theta sin theta. So p theta sin theta means this component. So already we have resolved force that p theta into ds into sin theta equal to 0. And we know that this element is very small. So element dx and dy already very small. So when we multiply, this become very small. So weight of this wedge can be neglected and equivalent to 0. So py into dx minus p theta into ds into sin theta. Here you see sin theta equal to dx by ds. So cancel out ds equal to 0, and dx is also removed. So py equal to p theta. Equation number 2. And from equation number 1 and equation number 2, we can see Px equal to P theta and Py equal to P theta. So we can say Px equal to Py equal to P theta. This is a Pascal's law. And theta means any direction. Theta you can take from 0 degree to 360 degree. You can rotate this P theta component to whole of the 360 degree. So any direction means P theta covers any direction. Px, Py covers 90 degree at 90 degree. But P theta covers at any direction. So Px equal to P theta, Px equal to Py equal to P theta means at given point, intensity of pressure is same in all directions. So let us see one very simple example to understand how we can apply it for the hydraulic jack. For hydraulic, for example, we want to lift a car having mass, having weight 2000 kg. So let us make a example. Let us take example. Suppose this is an example. This is a plunger and there is a piston here. We apply force F. Small F force applied. And here this is a car. This is a car. We want to lift it. We want to lift this car having 1500 kg. 1500 kg mass. There is a liquid inside. This is a liquid inside. Some oil is there, and in this oil we apply area is given here, area is given. Suppose area is here, area is given 50 centimeter square, and here area is given. This area is given. Area of this piston is given 1 meter square. 1 meter square. This is 15 centimeter and 1 meter square. So find out force required to lift this car. Find out force required to lift this car. To lift this car. How much force is required to lift this car? By applying pressure. By applying Pascal's law, we know that pressure at this point equal to pressure at this point. Both pressure are same according to Pascal's law. So F upon area. F upon area equal to where in this side force is given 1500 kg multiplied by 9.8 upon area. Area is given 1 meter square. 1 meter square. So force upon area. This area is given 50 centimeter square. 50 into 10 to power minus 4 meter square equal to 15,000. 1500 into 9.8 upon 1. So you can calculate force. F equal to 1500 into 9.8 into 50 into 10 to power minus 4. So you can cancel out minus 4, that is equal to 0.15 into 0.15 into 9.8, that is equal to 147. That is at 3. 1, 2, 3. So force required 1.47 Newton. You can apply force 1.47 Newton, and if this is 50 centimeter square area, piston area is 50 centimeter square, this piston area is 50 centimeter square, and this plunger area is 1 meter square. Then we can apply 1.47 Newton and we can raise a body of 1500 kg. That is a beauty. Around 15,000 Newton force you can raise by applying only 1.47 Newton for given condition. Lesser the area of the plunger, this piston, higher load you can raise, but process will become so. Here we are not getting any energy gain, but you are getting higher. We are multiplying mechanical advantage. There is no energy gain. It is not a violation of second law of thermodynamics, because here we are doing more work compared to our getting raising the load. Here we are doing more. Here we are getting lesser. Output is less always, but by applying a small force you can raise a very heavy load. That is the beauty of Pascal's law. So there are so many applications. That's why I have discovered here Pascal's law. I think you will like it, and there are so many applications. Even to develop relation of the pressure and the relationship between pressure, height, density, that is pressure P equal to rho GH. P equal to rho GH. Pressure at any height you can find by using this is the application of Pascal's law, by which you can derive equation P equal to rho GH. So that is I think good for you for any competitive examination and for conceptual clarity of the Pascal's law and its application, engineering application and daily usage application. So I think you will find it better, and please like and subscribe and share it to your friends. Have a nice day.